Hey guys, welcome back to Data Products with R. In this course, or this module, we're working on Shiny. In this example, we're just going to do a full-on example of what a Shiny app can be. And we're kind of going to build upon it. So the first one just showed you kind of the very basics of what a Shiny app is, the UI and the server. And what we're going to do now is we're going to build a more complex app. And then in the later videos, we're going to dive into details of specific things because I just want to show kind of what it's kind of capable of. And so believe me, you won't be lost if you've gone through my videos before. It's not as daunting as it seems. So let's hop right in. All right, so file, new file. Remember, Shiny web app, not R Markdown. We're going to call this ER example 1. Single file, and I'm saving it in my examples folder. Good. Okay, let's get rid of all this jazz again. All right. So first thing, library Shiny, and we're going to use a couple other ones. So if you're watching on line, you want library Vroom, and then everyone wants library Tidyverse. Actually, everyone can load these libraries. If you're doing this on Praxis, I'm going to throw the data up on Praxis in the starter folder because I noticed that the connectivity to where we're going to get the data is kind of sparse sometimes. Like, I'm not sure why that is. But I'm going to show you, if you're watching online, how to get the data, because that's been a request for those that are watching online that I may have neglected in the past. So I'm going to do that as well. Okay, so first thing we're going to do is we're going to use a new function that I don't think we've talked about in this course. It's directory create, or dir create. And so all that does is, in your working directory, it'll create a new folder. And whatever you put the name in the parentheses there, so in this case, Nice, that is what the name of the folder is. And let's look up what NEISS is the National Electronic Injury Surveillance System. So when people come into the ER with injuries, I knew what it did, but I forget what the acronym meant. But when people come into the ER with injuries, this goes into like a central database, and then you just kind of track this type of thing. All right, so we're going to download is going to be a function, and we're going to give it a name, and a URL is going to be, you're going to have to pause it because it's kind of long. Maybe if I remember, I'll post it in the description, so you can just copy and paste. But https raw.github.master-shiny/main/Nice. And then download file, paste 0. And we're going to paste 0 our URL and our name. And then we're going to paste 0 Nice name. And then we're going to quiet equals true. We don't want a bunch of stuff thrown out at us. And then we're going to end our function, right? So all this does is it says, all right, says download a file from our URL in this folder and be quiet about it. So I'm going to try running, you can't really run it because it's in a Shiny app. So if you are not on Praxis, this is the code you need to get the data. But I have the data already. So I'm going to do this, and I'm going to actually quickly grab the data just so I don't have a giant hiccup when I'm doing this. Okay. All right, let's keep going. So injuries. So this is kind of pre-app. So this is, again, if you are working with not having the data. So this says use Vroom, which is like kind of a opener to open this compressed file. Actually, you're going to have to do this if you're on Zoom or if you're on Praxis or not. Products. So this is, I don't know if I explained it very well. This will load the data because they are let me take a breath and not try to type and explain things at the same time because it's not been working. What Vroom does is it's a very speedy loader. And so what it will do is it will load data sets. These are tab separated files, which a TSV is. So it's kind of like read-delim or some of the other functions that we've used before to load data. But it can also deal with compressed files. So a GZ or a tar file or something like that. Vroom will be able to uncompress it and load it as well. And so population, so we're going to look at 3 different things. Population, Vroom, and then we're going to do, so you can see here, because I have a folder within my working directory that I've saved these in, the Nice folder, I have to put that before I say the name of the file. If you're just working in the same folder as your file is, you obviously don't need the Nice backslash. Okay, prod codes, we're going to say set names, products, from our prod code, products title, so this will give us a little more information. And so, okay, now, so we just wanted to, so this step pretty much just annotate, or loads and annotates the data that we downloaded with that previous app. So now let's make our user interface. So fluid page sets up our page. We're going to say fluid row. And we're going to say column. We're going to have 6, and then select input code product choices equals prod codes. And so again, once we create the app, we'll kind of compare to what we're doing here. Why? Oh. I just want to make sure my stuff all matches here. Okay. So let's put a comma here and do another fluid row and do column 4 table output diagonal or diagnosis, sorry, diagnosis, column 4 table output body part, column 4, why, 4 table, let's put an N in there, output location, and let's actually keep that there. Let's do another fluid row here. Make sure you get that comma in there. You saw me sneak it in. Column 12 plot output age sex, and then that's it for user interface. So why are you saying I have unmatched? What's going on here? 1 2 1 1 2 2 2. Oh, I should have one right here. There we go. That should fix everything. There we go. Okay. Make sure you didn't skip that one like I did. All right. So now let's make our server. Let me scroll down. Oh. I'll scroll down so you can kind of see here. All right. Server. So this is what's on the back end doing the work, right? Function. Take our input, output, and session. Seems common to the last app. Selected. It's going to equal our is reactive injuries. So reactive meaning that depending on, it's going to change depending on what the user selects. So they're not like stuck at one thing. And we're going to say filter by product codes, code equals input code. Okay, and then we're going to say output for diagnosis. We're going to render a table, selected. So we're going to render a table for whatever they pick from above here. We're going to pipe into count, diagnosis, WT equals weight, sort equals true. I'm gonna put that there. Let's see where I'm at. Weight equals true. Okay. Output. We're gonna do, let's do body part. Render table. Selected. And we'll pipe. So with piping, you can just pipe over or you can pipe down, depending on how you want to do it. In this example, I wanted to show that you could actually pipe across. So count, body part, WT equals weight, sort equals true, and we'll close that, and output location, render table, and then selected pipe into count, location, WT equals weight, sort equals true. We got that, we don't need that. Let's make these match. Okay. All right, so now let's also provide a summary. So we're going to graph it, but we also want a summary. So let's do summary, reactive, so it's going to change based on whatever the user selects in the input, and it'll change based on selected, which is their input. And we're going to do ggplot, so we're piping down this time, age, n, color equals sex, and geom lines, so you remember all the stuff in the ggplot section if you did it. And for labels, we're going to say y equals estimated number of injuries. Close that off. Now before we close this, we're going to put res equals 96. And then, okay, and then lastly, the thing we always do at the end of a Shiny app, Shiny app UI server. Ta-da! All right. let's cross our fingers that I didn't make any typos this time. Oh, of course. Fluiro. Where I wish it. See, the one thing the debugging isn't as good because it doesn't tell me what line. Fluiro. I'm gonna save it. Wow, one type. Well. Reactive. It tricked me for a second there. I thought I had it. Selected, yeah. Count. Oh. Why do I have aesthetic here? Oh no, I'm missing a thing. Wait, summary. Oh, I skipped. Alright. So, let's do. I skipped all over the place. So, move that down above summary. We're gonna do a new summary. Reactive. Selected. Count, age, sex, WT equals weight. Pipe down, left, join, population, by equals C, collection of age, sex, pipe down, mutate, rate equals N divided by population times 1E4. And then close that off. Okay, and now our previous stuff that we called summary, we're going to change this to output $ age sex. I'm going to say not reactive. Render plot. Man, I messed this up. All up. Alright. Summary. ggplot aesthetic age. Okay, the rest is alright. Alright, so as you can see, I kind of took like the first two lines of the summary statistics and put them as the first two lines of our plotting, and then just cut out the rest. So this is what it needs to be. So freeze for a second, alright, while I let you pause the video and copy it. Okay, let's save it and see if it works this time. I was like, man, I have one typo and it's gonna work. In reality, like, my script was completely a mess. What's going on? Alright, let's try this again. Sometimes if it freezes, like, I don't know what happens sometimes. There's a little stop sign down here. Oh, it's under my picture. So if you see my mouse kind of disappears too. Weird. So it's, yeah, like under the corner of my picture there. Alright. Hey, okay. So this worked. So we're taking our NEIS data, and we are importing it and taking our diagnosis, whether it's a laceration, a puncture, other fracture, a poisoning, burns, chemical, thermal, nerve damage, etc., what the body part is, and the location if it was home, sports, public property, schools, street or highway, or a farm incident. And then we're plotting it, right? So let's look at our UI quick. So we have a fluid page where we have our column number 6. Where did I scroll here to? Okay, and so that says select input or product. So one thing they really don't tell you is that in a Shiny setup, there's 12 sections across. And so when you give it a number between 1 and 12, it tells you how far to stretch that thing across, right? So if we look at, for example, when we look at our, where did we have our other numbers here? So our columns here for fluid row, we have 4, 4, 4, so that equals 12, right? So it stretches all 3 of these across the entire app. And then for our plot output, we had 12, right? And so that stretches the entirety. So I don't know why they picked 12. I'm sure there's some sort of computer science number behind it. But that's what those numbers mean. Like, it would have been hard to explain without showing it. So that's why we've kind of waited to go back and compare this to our final thing. So 6 means, even though it doesn't look like it, that it's stretched across halfway. And that the 4 means it's a third, and that 12 means it's all the way across, right? Oops, it disappeared my app. Here we go. So the first thing we did, and you notice that the order that you put them in is the order that they appear on the document. So at the very top, we had 6 across, and in this row, we said 6, put our input. We titled it product, and we used the codes, and then selected from codes from our NIST data. Then in our next row, we said print the table output for diagnosis, which we have here, for body part, where they cut themselves in this case, and the location. And then our third fluid row is just our plot output, and that's the user interface, right? Then we move down to server here, and so what's happening on the backside is it says, okay, take whatever our input is, make an output for this session. And so it says, for reactive, take the injuries section of the NIST dataset and filter to where the product code matches. So our product code is what is being sent to the server from this, right? So it says only show me the data for, in this case, we're using the product code to relate knives. We can change this to desks, chests, bureaus, or buffets. And so some of this, it's interesting because it's like, okay, this guy got injured by a desk, chest, bureau, or a buffet. I guess a buffet makes sense because I was like, how did they burn themselves on a desk? But a buffet, it makes sense that you could burn yourself, right? Suffocating, you could pull a desk over and not get on you and not get it, not get it off of you, I guess. Anyways, so it takes the input from this, and then it says, okay, only select out the stuff that matches that code. And then it says, okay, render a table for diagnosis based on filtering out from our code, so only the desk, chest. Let's pick something, toilets. That's another good one. So it says, okay, it says, build me a table that gives me the counts for anything with the code toilet from our master data set, right? And so then it does it again for the body part, and it does it again for the location, and then the summary. It generates a summary, and then it uses that summary to create this graph, right? So that's generally it. So it's kind of fun. We're going to use this more, but it's kind of interesting data to look at some of the groupings. Windows and window glass excluding storm windows. I mean, if you're working in an emergency room, maybe some of these make more sense to you, but like, I'm assuming EXCL is excluding. So if you get injured from windows or glass, but not storm windows, maybe they have their own category. Ladders, of course, that, tables not classified elsewhere, so specific tables that are not in the ceilings or walls. It's just kind of funny. And I feel bad for people that are obviously injured, but just the designations. Skateboards obviously have enough to have their own stuff. Amputation, electric shock from a skateboard. Some of these, like, you wonder the story. Poisoning from a skateboard? Someone tried to eat a skateboard? Yeah. But the other cool thing, so one thing too, that you'll notice, like, toilets. So the average age of somebody getting hurt by a toilet, as you can see, the distribution here, which is really interesting. So you see that, like, okay, you're gonna get hurt by a toilet when you're in your 80s. Like, generally you think of someone getting out of the shower, the floor slippery, there's probably a lot of fractures, contusion or abrasion, fracture, laceration, sprain, dislocation, hematoma, which is a bruise. So these are people falling into a toilet, right? And so you see that a lot at the older ages. But then you can look at some other ones, trampolines. Like, obviously, you're assuming that kids are going to get injured on trampolines, right? And it's true. So it's like, okay, 10-year-olds, number one for this. And there's another one I think I saw in here when I was playing around with it, monkey bars. Less than 10-year-olds, like 5-year-olds, the number one injury for that. So it's kind of fun data to play around with and kind of look at injured by footwear. That's just all over the place. So yeah, so you might want to, maybe it's just me. I'm surprised stairs or steps aren't. I guess people when they're older are generally, a lot of people when they're older decide to move to like a one-level house. Like my parents moved to a one-level house because you get older, and so maybe you know that risk. But anyways, oh man, we're almost at a half hour. Okay, so I'm gonna stop because you're just watching me browse the stat. I can do that on my own, right? So, okay. So I hope you enjoyed the video. The next one will be short, I promise. But in essence, what we're doing is we made a cool app. We took some of this nice emergency data, and I know a lot of you going into the med field, so this is pretty interesting stuff. You might be ER doctors. Just cool stuff to look at and you can kind of play around with. But we're going to make, for the next couple videos, we're going to take this and we're going to make our app better, essentially. You can see it's kind of, we have lists that don't match. It's not very visually appealing. It's fun. Like I like to surmise what's going on in these situations, and you might want to spend some time. Let me know if you make this, like drop a comment and be like, yeah, I looked at the data and I found this surprising or something. It'd be interesting. Or if you're in my class, post in the discussion or something like that. Are you guys geeky like me? Maybe it's just me. Like it's Friday night at 9 o'clock at night, and I'm having fun looking at data and talking to myself. Okay, we're gonna get under a half hour here, so I hope you liked the video. If you're watching on YouTube, please hit like, please hit subscribe. Let's get this out there. Let other lonely people on Friday night have something to do and learn how to look at NICE data. We'll make this look better in the next video. We'll keep working on our shiny apps. I hope you enjoyed it, and I'll catch you in the next one.